Hello and welcome to this series of videos which I call Java for the Reluctant. The intention is to give an introduction to Java for those of you who already know a bit of C++ programming. So I'm not going to go into details on all the small minute details on programming Java. I'm going to go over the major differences. As I go along, I'm going to do a working example and you can see for yourself that much of the code is relatively similar to C++. So you can probably get started rather quickly in Java if you know C++ already. Let's get started with a simple example. Just use the classic Hello World example. And include iostream and say that I want to join that namespace. I don't have to write std::: every time. And then a main function. Nothing strange or fancy about that one. And then in here do a cout and return. So this is nothing strange or new, this is just classic C++ as you've been taught. We can compile and run this and we get an output that says hello world. Now let's do this in Java. So in Java, everything is a class. So I need to say that I have a class. I can't have any methods lying around outside of a class. It has to be inside a class, which is what I'm doing here. And then I have my main function, just as in C++. And inside that main function, save, compile, here we are. We have the class hello world, we have a method called main, which is a static method, just as in C++. A static method means I don't have to have an object in order to call it. I can call it directly on the class, which is actually what Java does. We're going to get back to that one later. I have an output, so there's a class called system that contains all sorts of useful methods and attributes and stuff that you might want to have access to from your entire system. Inside this class there is an attribute called out, which is an output stream, just like cout, and on this output stream I can call the method println or println, and I'll give that a string, hello world, and that is the output that I get. So far nothing strange. I mean, this just looks just like, almost like C++. There's no big difference here. So let's dig deeper into what the differences might be. So in this series of videos I'm going to use an example which is Fizzbuzz. Now, Fizzbuzz is one of those classic programming examples that you can basically implement it with a for loop and 10 lines of code, but it's rather fun to play around with it and use it as a basis for this. So the core of it is that it should count numbers, 1, 2, 3, 4, and so on. And you get the idea. Now, if the number is divisible by 3, it shouldn't print a number, it should print Fizz instead. And if the number is divisible by 5, it should print out Buzz instead. If it's divisible by both Fizz and Buzz, it should print out Fizzbuzz. So this is the output that we expect from this program. What I'm going to do is I'm going to create a class that does this for us. In this class we are going to have a few methods. We have a few constructors that takes a map in the form, so it takes a map of fizzes and buzzes in the form of basically a number and a callout. So if the number is 3 and the callout is Fizz, for example. We want to have a default constructor that basically uses the standard Fizz and Buzz. So the first constructor means I can generate whatever Fizzbuzz example I want, and the default is to stick with the standard and just use Fizz and Buzz. What else? We're going to need a few methods here, and we're going to implement them, some now and then more later on. We're going to have a call number that basically returns either the number or the callout. So if I call number with 1, I'm going to get the return value 1. If I call with 3 in the default case, I'm going to get Fizz back, and so on and so forth. We are going to have one method called list, which returns an array of numbers or callouts, and we're going to have a method called count that does a printout of it as well. We are going to have another class where we want to put our main function in. Let's call it start. So we can have a main function there. And that's basically it. And the main function is of course going to do a few tests and stuff as well. So let's get started with the I suggest we start with the start class. That's an easy way. So I'm going to put that into a separate directory. In the source directory here, we're going to have a class called start.java. Now, since I named the class or the file start, I need to have a class called start. So I declare a class with the name start, and I want this to be available to the entire system. So everything in Java is actually inside a package, namespace if you will, in C++, and I want to, so if I don't say anything about what package it is a part of, it's going to be part of the default package. But I want this to be available outside of the package as well. So I need to declare it as being a public class. And we have our main function. And inside here we're going to create a few Fizzbuzzers. One with the default constructor, and one where I give a new, my own defined callouts. So I need to create those first, of course. What I do here is that I'm creating an array. So what I'm saying here is that calls is a variable of the type callout array, which means that it's an array that contains objects of the type callout. I haven't created the array yet. That's what I do with this bit, where I say that I want to have a new array with three places of the type callout, or pointing to objects of the type callout, to be more precise. And then we can start adding stuff into this array. And I want to have something like this. There we are, and then I can put that into the constructor like this. That should do the trick. Now what I'm doing is I'm creating a new object on this line and putting that into the variable fb1, which should point to an object of the type Fizzbuzzer. I'm creating an array, and for each slot in this array I'm creating a new callout, and then I'm creating another Fizzbuzzer object, and I'm giving this array of callouts to that Fizzbuzzer as in the constructor. So that should do the trick for this bit, for the start class right now. Now let's dig into writing the callout class, which is actually slightly easier than the Fizzbuzzer. So let's start with that one. I'm going to do this in a package, and so I am now in a package. I'm going to say now I need to tell Java that I am actually in the package. I want to have this class available inside this package. So I declare that, and then I have my class. Save that, and just to show you what I've done. So here's my start class, my start class, and I have created a directory structure, start directory MSV, subdirectory example, and in here I have my callout class. And so you see that the name of the package mimics where I put it into my file system. That's also by design, so you can it's easy to find your way around in a Java system like this. So let's implement this. I want to have my number, and I want that number to be private. Like this. And I'm actually going to do one more thing here, because that number, I would like to have that locked. So once I set that once, I don't want to be able to change that. So I tell Java that this number is locked. This I shouldn't be allowed to change that. It's a final number. That's like a const declaration in C++. And then I have my constructor. With a number and a callout. And like this. Oh, that should be enough. So let's compile this. Where am I? Here we are. Java compiler, javac, and I give it a Java file to compile. Now what's going to happen now is that it's going to, first of all, it's going to give me a lot of errors, because if we switch to here and start class, there's no way for the Java compiler to know that there is a class called Fizzbuzz, because the Fizzbuzz, it doesn't exist in the same package. So I need to import those. I need to import those two classes that I'm going to use. And now if we run the compiler again, I get a whole bunch of other problems. Why do I get those now? Oh yes, I haven't implemented the Fizzbuzz, I forgot that one. Of course. I'm in the same package, and I named my file Fizzbuzzer, so I need to name my class Fizzbuzzer. And in this class, what I want to do is I want to have a list of callouts. And list is just an interface, it's an abstract class, so I want to have a specific implementation of that. Like this. And then I want to have my default constructor. Actually, before I forget that. So list is something that I'm going to use from the standard libraries. And array list is something else I'm going to use from the standard library. So now I have the, now Java is able to find those things for me. That's always handy. My default constructor, and here I'm just going to add my two default callouts. Like this, and in my alternative constructor, what I want to do here is I want to take all the calls that I have in this array, and I want to put them into my array list, my private array list. I could do this with a for loop, but I'm going to cheat a bit, and I'll use another one of the standard, another class from the standard library. Because it's less writing for me. There. Now I have, let's see if this compiles. Still not. Did I, okay. Oh yeah, wrong variable type. There we are. But that's actually good, because we saw something else here that was I wanted to talk about before I got all these errors thrown at me. So when I give the Java compiler a start class, it's going to compile that one, of course, and it's going to look for all the other classes that I'm using inside this class and see, are they up to date as well? And if they're not, they are going to be recompiled as well. So this has recursively compiled my entire system. You see, I didn't write that I wanted the compiler to go compile the callout class or the Fizzbuzz class. It just did. So in a small example like this, I can usually get by using the Java compiler on my start class, and it's going to find most of the things. But there are some things to remember here. So if it finds a class which isn't touched, which isn't updated, it's going to stop compiling that branch of the tree. Doesn't matter if further down in that tree there are classes that have been modified. If it finds something that this one is not modified, then it stops compiling that branch of the tree. So it's not entirely reliable. You probably need to have a good makefile anyway, but it's a good starting point at least. So what have we learned now? We have, let's update this, we have our start class, and we have a package under msv.example, we have a callout class, and we have a Fizzbuzz class. What is this? To summarize a bit. Yeah. We have learned that everything is a class, or everything is in a class. There are no loose functions lying around. We have to have them inside a class. We have learned about packages. And we've learned that we need to import those parts of the package that we want to use. We have learned about the main function. We have learned about constructors. We've talked about standard libraries. Did I mention... no, I didn't show that. So if I may switch over to a web browser. Java has a relatively big library of standard stuff that comes with the compiler, and you can use them. So everything from string conversions to date formatting to file input-output and so on. It's well documented and it's quite advanced. Graphical user interfaces and stuff are there as well. So browse around there and familiarize yourself with the standard library, because it's really worth the effort. What else? We have learnt about the system out function. We have touched upon the arrays. We are going to work more with arrays later on, but we've at least touched on how to create them. and how to index them. And we actually even managed to brush into templates. If we go to the Fizzbuzz class, you saw these little brackets here. So that's not bad for a first video. And we've learned about the compilation process. Which is also good. And I'm going to leave it at that, and then we'll continue with how to use these objects that we created in the next video.